Okay, so now we will talk about the oxidation reduction reactions or the redox reactions. Um, the redox reaction it cannot be considered as a specific category of reactions like the previous six types. Um, Many of the previous reactions can be considered oxidation reduction reactions, and we describe the oxidation reduction reaction is that the reaction that includes a net charge change of charge in atoms. So the atom starts the reaction with a specific number of charges, and then it leaves the reaction with a change in the number of charges. So, in other words, we can say that one is oxidized, one element is oxidized, and the other is reduced. So that's why it has to be oxidation reduction. Cannot be only oxidation or reduction. Both have to happen. By oxidation, we mean the loss of electrons, and by reduction, we mean gaining of electrons or increase in the negative charge, and oxidation is the decrease in the negative charge on the atom. And that's why we define the oxidation number or the oxidation state, which is the charge the atom would have if it's not sharing the electrons in the compound, or it's not transferring the electrons to another element. Um, to make it clear, let's take a look at this. For HCl, we know that H is +1 and Cl is -1. This is how it looks like. Um, and This is the oxidation number of hydrogen, and this is the oxidation number of chlorine. And here we do not say that hydrogen lost the electrons to chlorine, but this is how we define the oxidation number. The hydrogen and chlorine form a covalent bond, and the bond is going towards the chlorine more than hydrogen, so we will consider hydrogen to be a positive and chlorine to be a negative charge. So this is a +1 and chlorine is -1. For sodium hydroxide, we know that sodium is +1 and OH is O is -2 and H is +1, and magnesium sulfate, magnesium is +2. This is its oxidation number. Sulfur is +6 and oxygen is -2. So it's important for us to know if this is oxidation or reduction reaction is to know which one of the elements that performed the oxidation and which one performed the reduction. And that's why there are some rules to assign the oxidation numbers first before we go ahead and see which got oxidized and which got reduced. There are some general rules for any element or atom or either it's an element that consists of one atom, or it's a diatomic like oxygen, like chlorine, like bromine, any of these. Its oxidation number is 0, so we consider the oxidation number of oxygen 0 and of the other oxygen is 0. Again, because it's symmetric, there are no charges here. For ions like sulfate, that's what we just mentioned for SO3, the oxidation number of the whole group is this number, which is -2. We talked about the radicals in here. So the oxidation number of ammonia is +1. For this whole group is -1. For this whole group is -2. For this whole group is -2, and so on. So this is what we mean by, for ions or for free radicals, the ion charge is the oxidation number of the whole thing. So I can tell that the oxidation number of this SO3 is -2 without getting to know what is the oxidation number of sulfur or for oxygen by itself. If you have a molecule, then the oxidation number of this molecule has to be 0. Let's just go back to the case that we mentioned here. For magnesium sulfate, the charge of magnesium sulfate is 0. The oxidation number of the whole molecule is 0. If you add these, and it is the summation of the oxidation number of its components. So I have magnesium +2, sulfur +6, and oxygen is -2. We have 4 oxygen atoms, so we have 4 multiplied by -2 equals -8, and then +2 +6 then equals 0. So this is what we mean here, that oxidation number values of the atoms in a molecule or a formula unit of a compound equals to 0. Um, So these are the general rules. There are some rules that are specific for specific groups or material or elements. So for group 1A, what we mean by 1A is lithium, sodium, potassium, and this cesium and this column in the periodic table. The oxidation number is always 1. For group 2A, it's always 2. We mean by this beryllium, calcium, magnesium, and this column. So the oxidation number is +2. For hydrogen, it's always +1. I mean, it's always it's +1 with it when it reacts with nonmetals, and +1 with it when it reacts with metals and boron. There is a compound that's called sodium hydride. So you have sodium reacting with hydrogen. So in this case, the oxidation number, because group 1A is always +1, so hydrogen will be -1 in this case. So oxidation number will be +1 in all cases except for the reactions of metals with hydrogen. For fluorine, the oxidation number is -1, and for this column, it's gonna be for group 7A, it's gonna be -1 in general, except in some cases, which is only reaction with oxygen, which is just one exception. So for group 7A in general, it's gonna be -A, -1, except when it reacts with metals and other non-metals. But for oxygen, if you have like hypochloric acid or something like this, it's not gonna be -1. Um, and for oxygen, it is -2, except for the peroxides. It's gonna be -1. Okay, so these are some general rules. I usually don't focus on the exceptions. I like to focus on the general rules um, that are like used in most of the compounds. Um, and some elements have more than one valence state, and we talked about them before, especially for the transition elements, that they have more than one oxidation state. And this is very common to use in the oxidation reduction reactions. Let's have a couple of examples just to study the oxidation reduction reactions and see what we can get out of these. So this reaction is between copper and sulfuric acid to form copper sulfate, SO2, and water. Let's put some again. If we take a look at the rules, for the general rules, it's important to keep in mind these rules. We will need this, especially the first and the third rule, that an atom or element will have an oxidation number of 0, and the sum of oxidation number of atoms in a molecule are equal to 0. Um, if you have a case like this, when you have an element that starts as an element and ends up to be part of the compound, then for sure, 100% sure, this undergoes either oxidation or reduction reaction, depending on how it started and how it ended. So what I'm trying to do now is to see which element that uh, was oxidized and which was reduced, and how this oxidation reduction reaction took place. So for sure I know that copper has done this or is part of this. So it started as copper with oxidation number of 0, and I know that SO4 is -2. This whole thing is -2, and um, this copper is the other part of the compound. This is -2. This should neutralize it so that the sum is 0. So copper should be copper +2. So it started as copper, which has 0 charge on it, and ended up with copper with 2 positive charges in it and 2 electrons. And we call this oxidation because the plus sign increased here. And now let's look at the other part. We know that some of them will not change. I know for sure that oxygen doesn't change. I know that hydrogen, from the rules that we just mentioned before in the previous slide, hydrogen and oxygen will not change because the special cases are not here. So I know that this and this are not going to be part of it. So the only element that's left is sulfur, and sulfur starts here as SO4. We just mentioned it before. It's +6, and again you can check it. You have +2, you have plus a negative 2 multiplied by 4, which is negative 8. So this is negative 8 plus 2, which makes it negative 6. So sulfur has to be positive 6. Um, the sulfate here is the same as the sulfate here, so I expect the sulfur here to have the same oxidation number as the sulfur in sulfuric acid. So I know that this and this have the same oxidation number, so no oxidation or reduction took place for the sulfur from sulfuric acid to copper sulfate. But I have sulfur here as well. Sulfur here is part of a molecule that consists of two oxygen atoms and one sulfur atom. The two oxygen atoms will be negative 2 multiplied by 2, which is negative 4. So sulfur here is plus 4. It started as plus 6 and ended up to be plus 4. So this is the second part of it. It gained 2 electrons to go from sulfur plus 6 to sulfur plus 4, and we call it reduction. And we have to make sure that the number of electrons that are gained by the sulfur equal to the number of electrons that are lost from copper, which is right, and which makes the equation like stable. The number of electron lost equals to the number of electron gains. The second example here is kind of more difficult, and we will take a look at it as well. It's lead oxide reacts with sodium chloride with nitric acid to form lead chloride, sodium nitrate, water, and chlorine. And in this case, again, I want to you before getting scared or getting worried about the equation, just to take a look at the element or the compounds that you have and think about the general rules. The first rule is to look for the elements. Again, I have here chlorine, which is an element. So the oxidation number of chlorine here equals 0. And I have chlorine here and chlorine here. So this should be part of it. So again, I look at the element. If it is there, enters as an element and comes out as a compound, or enters as a compound and comes out as an element, then you have this is part of the oxidation reduction reaction. So chlorine here, it's NaCl, which is again Na plus 1, Cl is minus 1. This is from the rules that we just mentioned. This is negative 1. And it came out here as negative 1 as well, because it's part of a compound. And here it's 0. So I have two chlorine atoms started as 2 chlorine negative 1 and ended up to be chlorine positive 1, which means that it's not lead. Let's take a look at the chlorine first. So the chlorine is gonna be it gained it lost 2 electrons, um, uh, and which means that it got oxidized. So the chlorine is oxidized. Now let's take a look at the other elements. We have oxygen. I know oxygen is always negative 2, so it's negative 2 here, negative 2 here, nothing changed. For sodium, it's positive 1, it's positive 1 as well. But before going into the hydrogen is the same. We are done with chlorine, so we have only lead, and we should look at the lead in the beginning, because lead is a transition element, and for the transition elements, we know that they possess more than one oxidation state, so there is a high probability of lead to be part of the oxidation reduction reaction. Let's take a look here. We have lead with 2 oxygen, 2 multiplied by negative 2, which is negative 4, so lead starts as positive 4. And here lead is lead chloride, which means that this is negative 2. So lead is positive 2. It starts as positive 4 and comes out as positive 2. So it gained 2 electrons. I'm sorry, this should go here. It's plus 2 electrons. Lead plus 4 plus 2 electrons. I'm sorry, it's a mistake. Which means that this is reduced, and oh, I messed up everything. this this is the other way. I'm sorry, this is a mistake. Um, Let me write it here. So this should go here, and this should go here. I'm sorry about that. And this is oxidation, and this is reduction. I'm sorry about that. So the lead gained 2 electrons to be lead plus 2. The number decreased by 2. And for chlorine, it started as negative 1 gained or turned into chlorine plus 2 electrons. So this is the oxidation reduction. Again, look at the elements and look at the transition elements. They are the, I mean, the elements that are not in compounds, and look for the transition metals. They are, or they have very high probability to be part of the oxidation reduction reaction. I hope it's clear. So that's all for this chapter, and I'll see you in the next video, inshallah. Goodbye.